How does O157H7 infect enterocytes? It begins when the bacteria uses its fimbriae to attach to the surface of the enterocyte. This is called fimbrial attachment. The next step is translocation of bacterial TIR. TIR stands for translocated intimin receptor. The bacteria expresses TIR and translocates it to the enterocyte membrane. The next step is called TIR intimin binding. The ligand intimin, expressed on the surface of the bacteria, binds to TIR located on the enterocyte. This binding allows the bacteria to be more firmly attached. At this point, Shiga toxin is released by the bacteria. On the surface of the enterocyte, Shiga toxin binds to its receptor called GB3 or GB4. The toxin is then internalized. Inside the cell, it acts to stop protein synthesis. This leads to cell damage and death, which can lead to bloody diarrhea. The toxin can then gain entrance into circulation and travel to organs throughout the body. The toxin may damage red blood cells, platelets, kidneys, and brain, and may even lead to death. Let's review now the steps in the pathogenesis of E. coli O157H7. Step 1. Attachment of bacterial fimbriae to enterocyte. Step 2. Bacterial TIR is translocated to enterocyte. Step 3. Binding of TIR to intimin. Step 4. Release of Shiga toxins. Step 5. Binding of Shiga toxin to GB3, GB4 receptors. Step 6. Shiga toxins enter the enterocytes and stop protein synthesis. Step 7. Enterocyte damage and possibly death. Step 8. Shiga toxins enter circulation. And finally, Step 9. Damage to RBCs, platelets, kidney, and brain, and possible death.